Last video for this chapter, ladies and gents, is star clusters. I mentioned last time that stars have a tendency very often to be born in clusters. They get born in groups, sort of like a litter of puppies or a litter of kittens. They're all born pretty much at the same time. So as they age, they are all pretty much the same age. I said that a minute ago. Sorry about that. How many stars will be in a star cluster? You can have dozens or you can have hundreds. And there are different types of star clusters. This is a absolutely beautiful picture of a star cluster. Absolutely stunning. There are two primary types of star clusters. One is called an open cluster. The other kind is called a globular cluster. Now, an open cluster of stars are irregularly shaped. This is a picture of an open cluster of stars. The actual cluster itself does not have a lot of structure. It doesn't look particularly round. It doesn't look particularly oval. It is just a collection of different stars that are kind of wadded up together. They are bound together by a mutual attraction of gravity, and they are usually found within the plane of the Milky Way. And here's what I mean. If the Earth is, and we're about two-thirds of the way out on one arm of the Milky Way galaxy, when we look back at the Milky Way, open star clusters tend to be in the plane of the Milky Way. They are our neighbors that are residents of the Milky Way. And if we were standing on Earth, looking at the Milky Way above us in the sky, where are you going to find open clusters? You're going to find them in this area here, because this, when we look at this, we are looking from our vantage point on Earth, we are looking through the plane of the Milky Way. The second kind of star cluster is called a globular cluster. Globular clusters are absolutely stunning. They're very, very symmetrical. They have a tendency to look like loosely held together snowballs. Very, very bright, lots of pretty little sparkles everywhere. And they're found in a different spot. Globular clusters tend to be found above and below the plane of the Milky Way. So if this is us about two-thirds of the way out on one arm of the Milky Way galaxy, where are we going to see globular clusters? We're going to see globular clusters above and below the plane of the Milky Way. We're going to see open clusters when we look through the plane of the Milky Way, and globular clusters when we look above and below the Milky Way. Globular clusters, there are very few that we can see. There are only about 180 that are known. They look like kind of faint fuzzy balls, sort of like puffball dandelions, and they exist above and away that plane of the Milky Way. All stars in the same cluster, as I mentioned, were formed at the same time. They have the same age. So if one of them turns into maybe a variable star, something like that, we then know the age of all of its neighbors. Very often, if we find the chemistry of one, the chemistry of its neighbors tends to be very similar because they'd had the same birth parents, which was the same nebula, the same gas cloud. So, to differentiate one last time, open clusters contain stars like ours. These are going to be older objects, these are going to be younger objects in space. Right? Younger objects, meaning they have not been around as much. So open clusters are like our sun, mostly hydrogen, some helium, about 0.2% other stuff. They're going to contain elements like oxygen, calcium, iron, sodium, and some of the heavier metals. Globular clusters, which are located, if this is the Milky Way galaxy, they're going to be above and below that Milky Way. These lack the heavy elements. They don't have calcium, oxygen, iron, sodium, and things like that. They're made of more primordial, older stuff, older stars. So these things can be maybe in the neighborhood of 12 billion years old. Remember, when you look through a telescope, there's a thing called look-back time. The speed of light can only travel at a certain rate. And so when you see something and the light has traveled for a long, long time, That means that it is further away in time and further away in distance. Globular clusters, when we see them, do not have O-type stars. On our Hertzsprung-Russell diagram, in this corner, we have these O, be a fine girl, kiss me, the O stars up here that are very, very hot, and they're very, very luminous. They're very, very bright. So what does it mean that a globular cluster does not have hot, bright stars in it? Basically, it means the globular clusters are so old that the stars that are in this corner of the Hertzsprung-Russell diagram have died off. Blue stars have a tendency to live fast, die young. And these guys have lived up their life long before the 12 billion years old that we suspect globular clusters are. Why is this important? It helps to give us a minimum age of the universe. If we can see things that are at least 12 billion years old, what that means is our universe is at least 12 billion years old. So we'll talk about how we have aged the universe over time, but this is one of the many pieces of that puzzle. And that, ladies and gentlemen, concludes this chapter. See you next time.